So last we discussed till question 9, so we'll move on and onward. Question 10. In question 10, when enantiomer of a 2 is you can read. When enantiomer of a 2-iodobutane react with the sodium hydroxide, the mixture of the product is a mixture of enantiomers. This is because so we have 2-iodobutane. This is 2-iodobutane. And then when we add with the sodium hydroxide, first which one is this? It is a secondary halogen alkane. The carbon is surrounded by iodine, like carbon is bonded with iodine, and it is a secondary halogen alkane in which this is partial positive and iodine is partial negative. So when there is an attacking nucleophile, the attacking nucleophile will attack on this carbon positive. Okay. The reaction, this is because the reaction is nucleophilic substitution reaction. It is producing only one type of enantiomer. Even, it is a nucleophilic the reaction proceed by a negative charge transition. If a carbon, because when we have a SN reaction, SN can be SN1 or SN2 reaction. So how it can proceed? If it was a SN1 reaction, then the carbon cation, if it was SN2, the bond breaking and a bond forming will take place at the same time, and the carbon cation will be negative. Okay? Because like this will be hydrogen, this will be hydrogen, and this is like example CH3, this is halogen, and this is an attacking nucleophile. So bond breaking and bond forming will take place at the same time. In SN2, the intermediate will have a negative charge. But in SN1, first the bond will break when we have a tertiary halogenoalkane. First the bond will break, so it will form a carbon cation. And there will be a negative charge. So this is a carbon cation and there is a negative. So what about this one? The attacking nucleophile can attack from the left-hand side or can attack from right-hand side. So it will produce two enantiomers or a racemic mixture in SN1. So when there is a SN1 reaction, a nucleophilic substitution reaction, one order means it will form both enantiomers or a racemic mixture, but it is forming only one enantiomer. So one enantiomer is formed in SN2 reaction. And when SN2 reaction is formed, the intermediate, the reaction proceeds by a negatively charged transition state. So when SN2 is there, the transition state is negatively charged. When SN1 is there, the transition state is positively charged. So what is the answer? Answer should be B. Clear? Because it undergoes a substitution reaction. Substitution reaction can be SN1 or SN2. If it was SN1, then it will form a carbon cation and it will result in a formation of two enantiomers, which result in a formation of racemic mixture. Both optical isomers will be formed. But here in the question they mentioned, they mentioned the product is a mixture of enantiomers. So if it's a mixture of enantiomers, then C will be the answer. I thought only one enantiomer is. Okay. The mixture of enantiomers, SN1 and C will be the answer. If it is only one type of enantiomer is there, then B will be the answer. Yeah.
So usually the SN1 reaction result
in racemic mixture.
Yeah. So
yeah. And that is what we want. They mention a product. The product is a mixture of enantiomers, means it contains both. Then how many structural isomer with a molecular formula C5H10O react with a toluene reagent? What is a toluene reagent? The toluene reagent is the one which can oxidize, like it can itself, it is reduced and oxidize the other substance. So one O is there, so it can be aldehyde or a ketone. If I have 5 carbon atoms, primary and secondary can be oxidized, but tertiary cannot be oxidized. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because we want C5.
So this is for
What?
so it is for
The tolly, no, we can also check with the primary because some primary can also, but the molecular formula is not C5H10. For the alcohol, if it was an alcohol molecular formula with a 5, alcohol can also be oxidized by a toluene reagent. But we have 1, 2, 3, 4, 5 carbon are there, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12O is there. So it means it cannot be alcohol, it should be an aldehyde. So which aldehyde? Like ketone cannot be. So we need 1, 2, 3, 4, and 5. This is one possibility. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This will be oxidized. Then we just, because aldehyde can only be at the last, it cannot be in between. So I will just change the structure. It will make a branch. This is one possibility. Then we make a branch. This is one possibility. Yeah, that I'm making the other. One, two, three, 4, 5 are there. This is one possibility. Any other possibility there? You mean like this? No, that will be same as this one. What you're saying? No, I got your point. Like what you're saying is like this, huh? But this is the same. 1, 2, 3, 4. Same as I select the longest chain of a carbon. So second is the branch. So this is same. Branch can only be there from second to the second last carbon. Cannot be with the first. So means 4 possibilities are there. So C should be the right answer. Okay. Yes. Yeah, but that equation, there is equation for. But that equation also needs working. So it's better draw the structure rather than use that equation. Yeah, longer method is there. Propanol react with iodine. Like if I want the isomer of, let's say I want an isomer of C5. So I have to make, to use that equation, I have to make an isomer with a 4 and then I apply the equation. So it's like number of isomer of 4 plus 1. Okay. Like example, if I say, how many isomers of butane are there? This is one isomer. This is the second isomer. There is no third isomer. Okay. I cannot draw like this. 2 isomers are there. So the rule it was n plus 1. N plus 1 is a rule. So, but it is applicable, like I will draw n is the number of the isomer of the previous carbon. So if C4 is having, like this is 4, I will make 3 and I can, this is the only way I can draw. So what is the value of n? N is equals to 1. So 1 plus 1, what it makes? 2. For the carbon, yeah. So I have to work out isomer of the 3 and then add 1. So that is also a rule of writing the structural isomer, not the optical. In question 12, propanol react with iodine in both acidic and alkaline condition. The product of a reaction in acidic condition and in alkaline condition, it will produce triiodomethane. And I think D will be there. 12. Yeah. If you see, in acidic condition, this is a propanol. it reacts in acidic condition with iodine and H plus ion. So one of the iodine take position of hydrogen in acidic condition. So it will form isopropanol. This is isopropanol. That's a product in acidic condition. But in alkaline condition, what will happen? Because in alkaline condition, it is also a test to check the methyl group next to carbonyl group. Idoform. So when we carry out in alkaline condition, this will break, like this CH3 will be removed, and this CH3 will combine with iodine to form CHI3, triiodomethane. I did not balance the equation. Equation must be balanced in the presence of NaOH. So this ONA will take position of a methyl, and the methyl group combined with the iodine to form triiodomethane. So triiodomethane is CHI3, and this is in acidic. So you have to remember in acidic and alkaline.
So, keep on in the case of acidic fusion reaction, but the
Alkaline, it will undergo. Yeah. Yes.
The question. When they say like a mix of enantiomers, it's not necessary that it's
Racemic mixture.
Why?
But mixture of enantiomer means it has both isomers.
Yeah.
It has both isomers, but maybe it's not a racemic mixture.
Yeah, but that only can be derived from
SN1 reaction. The equation for a reaction between propanol and iodine is shown. The reaction is carried out at different pH values, all other conditions kept same. In the first reaction, the pH is 2. The second reaction found to be 1/3 of the original. What was the pH of the second reaction? So, pH of the second reaction to 1 decimal place. So, pH is equals to minus log of hydrogen ion concentration. The first reaction, the pH is 2. The second reaction, it was found to be 1/3 of the original value. So actually, look how we can do. You can see the rate of a reaction is directly proportional to hydrogen ion concentration.
Yeah.
The second reaction rate is decreased by 3.
Yeah.
So hydrogen ion concentration is also decreased by 3. First, we'll find what is the original hydrogen ion concentration. What is the original hydrogen ion concentration? We'll take, because the hydrogen ion concentration will be equals to 10 raised to the power minus pH. That is how we got the hydrogen ion. So 10 raised to the power minus 2. What is 10 raised to the power minus 2? 0.0. So 0.01 is a concentration. But the second experiment, it is 1. If the rate is decreased by 3, hydrogen ion concentration will also decrease by 3. So it will be 0.1 divided by 3.
3.
So 0.003.
Yeah.
That is a new concentration. Now we'll find the pH. So pH is equals to minus log of hydrogen ion concentration. So minus
2.4. 2.4.
So minus log of 0.003. So we got 2.47. So 2.47, which is equals to 2.5. Okay. So that's how we, from a rate, we identify, because the rate of a reaction decreases by 3. So the hydrogen ion concentration will also decrease by 3. If the hydrogen ion concentration decreases by 3, first we work out what is the original hydrogen ion concentration, and then it is divided by 3. And then from that new hydrogen, we got the pH. In question 13, butene and 1,4-diol may be converted into 2-oxobutane butane dioic acid in 2 steps. The synthesis through the intermediate W. Identify the intermediate W. Look, here we have, this is alcohol is there. Okay. Basically what we did, we break the double bond. Like what is the change? It is butene 1,4-diol. Okay. Then it turn into 2-oxo, means second group oxygen is there. Butane dioic acid.
That's the final.
That's the final product. Means these OH groups has been converted into a carboxylic group. You can clearly see here. Okay. And this group, the double bond is break down. The double bond is break down. And what we have in between, if I draw the structure of this compound, it is OH, C double bonded with O, then C double bonded with O, and then CH2, then C double bonded with O and OH. This is the compound. It has two carboxylic group and it has one ketone group.
Yeah.
And about this compound, the original compound was diol. So first thing, alkene we want to convert into aldehyde. So what we should do? Look, for the second stage, I want to convert, I want the oxidation of alcohol, the second stage. So alcohol must be oxidized. What is the oxidizing agent? The oxidizing agent is potassium dichromate is the oxidizing agent. Because of alcohol, we have these alcohols and finally they are converted into a carboxylic acid. So means the oxidizing agent should be there. And here we add a steam and sulfuric acid. So when we add a steam and sulfuric acid, so what will the product? The double bond will break into a single bond and one will have a hydrogen and one will have OH. Okay. So it will be both side alcohol. Both side OH group will be there. Once, like for original compound, CH2 is there. One will have a hydrogen and one will have OH. Clear? No, it is because we use an oxidizing agent. So this is converted into alcohol first, and then alcohol being oxidized to a ketone. No, this is alcohol, but when we react, this steam and sulfuric acid, this is a reaction condition for hydration. Hydration.
Okay, so in order to break the double bond.
In order to break double bond. So when we break a double bond, one will get OH, one carbon, another will get hydrogen. And then we use an oxidizing agent. The oxidizing agent convert this alcohol into a carboxylic acid, this alcohol to a carboxylic acid, and this secondary alcohol to a ketone. Secondary alcohol will turn into a ketone.
This is ketone.
Yeah. So that is what happened.
So like there's a ketone.
Next is the compound X, which is C4, H10, and O is oxidized to form a compound Y. Compound Y react with ethanol in the presence of concentrated sulfuric acid to give ester Z. What could be the formula for ester Z? First thing, this is an alcohol. How we identify it's an alcohol? Because only one oxygen is there. So this is C4, H9OH. So this is alcohol, butanol. So one side, and it is forming ester Y. And it react with, compound Y react with ethanol in the presence of compound X is there, is oxidized. Okay. Compound X is oxidized. So means it, compound X is this, it is oxidized to form a carboxylic acid because this is X. Okay. And it will be oxidized. So if it is an butanol, butanol will be oxidized to form butanoic acid. So it will form C3H7COH.
This one will react with
this will react with ethanol. So if C3H7COH will be there and it reacted with ethanol C2H5OH. So this two will take position. So it is C3H7COO C2H5. So it means one side there should be 2 carbon and another side 4 carbon should be there. Okay. So One side 2 carbon, another side 4 carbon. That is one possibility.
Oh,
Because we are talking about possibility. But the part which is attached here with single bonded with oxygen is always from alcohol. So on the right hand side, we should have 2 carbon. Okay. Because the part which is COO, this part is always coming from alcohol. And this part is from the acid. So this is having 4 carbon. So this is not the right. This part is having 3 plus 1, 4 carbon. That's not right. This is having 2. So they mean this is from ethanol. And 1, 2, 3, 4. So this is from the acid. And this is also wrong because it is coming 4 carbon. So this is not correct. So C is the right answer. That ethanol react with this acid to form. So it was not exactly butanoic acid. It was a branch, maybe 2-methyl propanoic acid. So when 2-methyl propanoic acid react with ethanol, it will form ethyl 2-methyl propanoid.
so, and I'm going to react with another one from the form acid.
Yeah, so alcohol oxidized to acid, then acid reacted with alcohol to form an ester. So sulfuric acid is a catalyst for esterification.
Should we know how it's involved in the reaction? Should we know how
No. It's a homogeneous catalyst. It has the same state as the solution. Which of the following compound is a product of hydrolysis? Hydrolysis means breakdown. So if I do breakdown, this is an ester. This part will be alcohol, so C3H7OH. And this will be a carboxylic acid, so CH3COOH. Okay. But then we add a sodium hydroxide. Reflux. So the acid will react with the sodium hydroxide. So if we have CH3COOH and it reacted with sodium hydroxide or NaOH, so sodium will take position of a hydrogen. So it will form CH3COONA plus H2O. So it will form sodium ethanoate. And C3H7OH. So B will be the right answer. Because this will be the product, C3H7OH, or CH3CONA will be the product. Because it is hydrolyzed by breakdown. Yeah, because when we do hydrolysis, we break down the ester into acid and alcohol. But acid, because it's a base hydrolysis, so the acid will react, the ethanoic acid, which is formed, will react with the sodium hydroxide to produce sodium ethanoate. In question 16, in a gas chromatography, a gas containing a mixture is passed over a liquid stationary phase. The main reason a mixture is separated into a component is because they have different attraction, because different attractive force to the liquid. As in a gas chromatography, gas containing a mixture is passed over a liquid in a stationary phase. So liquid in a stationary phase, because they have a different force of attraction. That force of attraction, like example, particle A is there and a particle B. So when they are moving, because of a different attraction, one will slow down, like one will move faster than the other. So they are separated from each other. Greater the attraction difference in the attraction forces, greater the retention time. In a high performance liquid, mobile and the stationary phase. What is the mobile phase in HPLC? High performance liquid chromatography. High performance liquid chromatography. Mobile phase and the stationary phase. The solid is a stationary phase and the liquid is a mobile phase. You have to memorize this HPLC. Mobile phase is the phase which is moving and the stationary phase which does not move.